So here I have MATLAB Online open. You can see I have a folder that contains all my theoretical reference material that you can upload to your MATLAB drive in order to reference during your exam, keeping in mind you only have 2 hours to solve 6 problems. And here I have a folder that I'm going to go ahead and write all of my midterm files in. And here on my right, I have all of my practice exam questions. So I have revised these questions, but I have not written them. So we'll go ahead and go through solutions, and I'll talk through my raw solving process. So it says, in mathematics, the Pell numbers are an infinite sequence of numbers, blah, 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 blah. This sequence begins with 1 and 2, and each subsequent number is the sum of Pn minus 2 and 2 times Pn minus 1. And here's an example that's really important. So it begins with 1 and 2. And then write a function file that takes in an integer number, n greater than 2, and returns p as a vector of the first n Pell numbers. So if n is 5, that means I need 5 Pell numbers. And a vector n5 as the number of elements that are in p that are divisible by 5. Your function must do the following. If n is not greater than 2, then assign both outputs at negative. Okay, so here I have some decisions to make, which means I need branching. I also have decisions over here, divisible by 5, another decision. So that's more branching. And then I'm going to go ahead and do an infinite sequence of integers. This means I'm going to do looping. So let's go ahead and write this code. So I'm going to start by not writing it in a function, just to start with something. So let's say n is 10. I want to write the first 10 Pell numbers. So I'm going to go ahead and say p is zeros, 1, 10. Doesn't matter if it's a row or a column, but it's 10 values. P of 1 is 1, because that's what it says over here. The first number is 1, and P of 2 is 2. So I'm storing my numbers in a vector because that's my output. P is a vector. Then I want to go ahead and fill all of the remaining numbers, which means P3 would be P1, so n minus 2, so 3 minus 2 is 1, plus 2 times P2. And P4 would be P2 plus 2 times P3. And hopefully by now you're noticing a pattern where I'm repeating Pi equals Pi minus 2 plus 2 times Pi minus 1. So 4, my first I is 3, and my last I is going to be all the way to n, or the length of my vector. So rather than being 10, I'm going to say n. So I'm going to go ahead and run my code, see if it works. Arrange these must be positive or logical integers. Here. So I is 2 to n. Evaluate 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, nope, I started at the wrong number. Started at 3. There we go. Run my code. Okay, 1, 2, 5, 12, 29, 70. Okay, so it matches the example that I see over here. So I'm starting with the right set of numbers. Now I can go ahead and fill in some other things. So in order for this code to work, I need this. So here's my working function code. And then I can do some other things. So first thing I can do up here is I can go ahead and do this branching statement that says if n is less than 2, or if n is greater than 2, then I want to actually do this. Else p equals n and n5 equals n. Here's my error checking. There's my branching statement. And then another thing I want to do is I want to go ahead and figure out which numbers are divisible by 5. So I can do that in this loop here, but I'm going to do it in a separate loop just because. Then I can go ahead and count. So here I'm going to say n5 here. 5 equals 0. That's my count. I'll say p is defined. We'll put that in here. n5 equals 0. for I equals 1 all the way to the length of p. And this is how you iterate through a vector. And then I want to go ahead and decide whether or not they're divisible by 5. So to do that, there's a couple ways to do that. I'm going to use the remainder function. So if pi, is it a rem pi divided by 5, if that remainder is equal to 0, then it's divisible. So n5 equals n5 plus 1. I'm going to increment my count. Run my code, see if it works. Look at n5. n5 is 3. Yeah, hey, that works. That matches this example. Okay, so last thing I need to do is go ahead and wrap it in a function. So I'll start with the word function. E n5 L. There we go. I have my working code. So there's a lot going on in here, but I've built it piece by piece. Then I can go ahead and delete all of those comments there at the top, and here's my function. If I want to test it with the example, I could just go ahead and type that in. P, comma, n5 equals L10. That works. And I can see it matches my example. You can see they're all squished together, but it's the same numbers, and n5 is 3. I can also check to see, okay, what if it's 15 numbers? I can go ahead and check to make sure it works for multiple different values as well. So building it piece by piece. Moving on to question 2. So question 2 says that we want to go ahead and write a function file, count primes, which takes in integer n and returns an integer n primes, which is the number of primes between 2 and n inclusive. Okay, and here's my example. So essentially, what I'm going to do here is takes in an integer n and returns n primes, which is the number of primes. So I'm counting something. Counting number of primes. That counting depends on whether or not a number is prime or not. So that means I'm going to go ahead and make a decision, which means I need some sort of branching. And then counting usually means that I'm going to do some sort of looping. And then it says hint, use the is prime function. If you want to know what is prime is, we can just go down here and say help is prime. You can't Google things, but you can use the help command. So is prime is true for prime numbers. Is prime x is 1 for the elements of x that are prime, otherwise. Okay, so I can just go ahead. I'll do this in a function right away. Function n primes. You can call it whatever you want. N equals count primes n. So count the number of primes between 1 and n, or between 2 and n. So for 2 to n, I equals 2 to n. I want to see if I is prime. I'm going to go ahead and start my count at 0. So here's my initial count, or my initial sum. And then if is prime I, then n equals n. And it's pretty much that simple. That's what that looks like. Not a very complicated function. Let me go ahead and check. So n equals count primes. Oops, I didn't save my function, my file. There we go, n is 14. So that matches my example, which is great. I can go ahead and count the number of primes. No, I don't want that one. Count the number of primes, and let's count between 1 and 100. It's 25. But here we can see a very small, really simple function where you're just iterating through a bunch of numbers and checking to see, okay, are they prime? Are they not prime? Classic branching inside of a loop. Problem number 3. Write a function file. There's lots of functions in here because every single problem on your midterm, you have to write a function. If you don't know where to start, then just don't write a function. Write some basic script file. There's lots of not extra credit. There's lots of partial credit on your midterm that you're gonna get. It does not need to be perfect. So any code you can write is fine, but there are lots of functions here. Write a function file b equals modify array that takes a square array of arbitrary size and n as an integer equal to the required size of the new array b. So your function must do the following. If n is less than m, okay, note, I've got the if here, that means branching. If n is less than m, the function must assign b with a, where a is reduced in size from m to n by n, by deleting rows and columns of the bottom and right respectively. And then another branching, here's the a is increased in size by adding rows, and then here they're the same. Then b must be assigned with a. So let me go ahead and start with values. A equals, I'll do the one that they gave me, 5, 5, 4, 8. And then n equals 3. Once again, I'm going to start by not writing the function. This would be my function code in here. So now I'm going to go ahead and write code based on a and n. So m is the size of the array. So that means I need to go ahead and get the size of a, which rc equals size of a. There's multiple ways to use the size function. I like to use this one because an r and c are in different variables. So that means r and c should be the same. They should both be m. Should be square. It's supposed to be square. Square array. So m and m. M and I'll just do m. A size 1. Or length, either way. But I have the size of a. Now I want to go ahead and do my branching. If n is less than m, else if n is greater than m, then else, this is where they're the same. I'll go ahead and do the last one first. B equals a. That was the easiest. B equals a. Just change it. Okay, so if n is greater than m, or if n is less than m, I need to delete parts of a. Not a great example for this, but I need to delete parts of a. So that means I'm going to go ahead and write my own example over here. If a equals 1, 2, 3, 4, 5, 6, 7, 8, 9. So here m is 4. Let's say n equals 2. I need to delete these rows and these columns. Essentially, one of the things I'm going to do is I'm going to go ahead and say b equals a 1 to n, 1 to n. Rather than delete things, I'm going to go ahead and keep them. Another way I could do it is I could say b equals a 1. Option 2 would say b equals a, and then b equals b n plus 1 and n plus 1 and equals empty. So here's option 2. Option 1 is keeping. It really just depends on how you want to view it. In the document over here, it says to delete, but ultimately these are the same thing. If n is greater than m, I need to go ahead and add to b. So here's where this example comes into play. We're adding in these zeros. So I'm going to go ahead and start by saying b equals zeros, n. So start with b equals zeros. Here's option 1. And then I can go ahead and say b, 1 to m, comma 1 to m. So insert a. Option 2 would be concatenation. So I could say b equals a, place next to zeros with the same number of rows as a, and then the columns would be minus n, something like that. placed on top of zeros and minus m, comma n. Something along those lines. But the thing is, I can go ahead and test my code. So if you don't trust everything, you can go ahead and execute it one line at a time. So let's say n is 3 and m here is 2. I can go ahead and check my code here. I'm pretty confident in this code. There we go. There's that B. Or if you don't want to, here, I don't really trust that. Okay, that one works as well. Let's go with the example that I had over here on the side, where A is bigger. So I'll just make it random. 4 by 4. And let's say n was 2. Highlight my code again. Here, this one. Okay, so there's something wrong. A null assignment can have only one non-colon index. Oh, I have to delete rows at a time. My bad. So you can't delete you can't delete rows and columns together. You have to delete a single row or a single column. So let's see if this one works. Yeah, that one works as well. So it deleted A. Same thing here. Be keeping pretty confident in that one. Okay, so my solution works. So I go ahead, run my code. To call it. Supposed to call it modify array. Run my code. Okay, no errors. Here's my function code. So I'm going to go ahead and replace all of this. My function. Function B. A. Just as a note, the document over here gives one example, but I have 3 branches here, so I should really test all 3 of them. So first I'm going to say A equals random integers between 1 and 10. That's a 4 by 4. Then I can say, okay, so that means m is 4, and I can test it to say, okay, what if n is 2? And I'm going to go ahead and call my function. B equals modify array A n. Okay. Come on, Madeline. So if A look like that, n is 2, it goes ahead and keeps the top corner. Now I want to go ahead and increase n to 6. There we go. I can see that it added rows and columns. And then I will say, what if n is the same and b stays the same as a? So I've tested all 3 branches and make sure that it works. I have it in my function. And there we go. I'm done with that. Moving on to question 4. Question 4, write a function file that takes inputs. X and Y as 2 vectors of arbitrary length and calculates the following function. Okay, so if the numbers here's my function. Note 2 vectors. I'm doing math here. I need to use element-wise operations. I'm doing vector math. I'm doing math with vectors. If the number of elements, okay, so if branching, so if the number of elements in X and Y are not the same, assign with NaN and arrow with true. If the numbers are the same, assign using the equation and false, and then display the calculations in the following format. So let's go ahead and start with some code. So let's say X is 1 to 5 because that's my example. Y is 11 to 15. Once again, that's from my example down here. And I'm going to go ahead and do my calculations. If length of X equals, or is not equal, length of Y, then Z equals NaN, error equals true. If they're not equal, that means they are equal. And that means z is my calculation. 0.6 dot times, I'll just do normal x cubed times exp to the negative 0.47 times y plus 1.5 times y squared times exp negative 0.6 times x. Okay, so I've typed my code with normal array or with normal mathematical operations, but I'm doing array math, so I need to go ahead and go through and put a period in front of all the asterisks, caret signs, and division signs. Some of them are not required, but you're not penalized for it. For example, this one's not required because this is a scalar times a vector, but once again, you're not penalized for it. Save my file before I forget. Function calculation. Run my code. Make sure it works. It does. Z, looking at the answers. They match that. So I'm going to go ahead and now print out my results. So I want to display. It doesn't say what function to use for display. So this here is using the disp function. You can also use fprintf. Your code does not need to match these lines exactly. There's a lot more freedom when it comes to your midterm problems because we are manually grading it. We're going to run your code individually, give you partial credit, all that fun stuff. But if I want to use the display function, I can display x, display y, and display z, and display my array of values. So my x values transposed, my y values transposed, and my z values transposed. And then I can go ahead and align it. Run my code. They're lowercase x. Run my code and align. I don't like the way that's formatted, so I'm going to say format G. There we go. Line up my manually, test it, I'm almost there. There we go, it's nicely aligned. So that's what it can look like with disp. With fprintf, I have a lot more control. I'm gonna go ahead and my first line, my header, and then I'll print out my data. So 4%4d, %4d, %6.3f, new line. Comma, and then my data. Same data. X, placed on top of Y, placed on top of Z. Capital Z. And that's what it looks like there. Boppity bop. I need more space for my space things out a little bit more. There we go. There we go, those are nicely aligned. So we can see the difference between what it looks like with disp here versus fprintf. With disp, there's no control over the spacing. You just have format short G and it just picks the spacing at once. With fprintf, we can align things a little bit closer. And I have more control over what that looks like with the number of digits past the decimal point and all that fun stuff. So that's what it looks like for those two. The last thing I need to do is go ahead and convert it into a function. So function, my output is z, and error. Forgot to assign error with nothing. Error equals false. There we go. Error equals function calculation x, y, and then every function has an end. Delete that stuff from the top or comment it out. Either way, doesn't matter. And then I can go ahead and test my function down here. I can say z error equals function 1 to 5, comma 11 to 15. We can see what it looks like. If you don't want that printed out, there you go. Note we have 2 branching statements, so I want to also check to see if my second branching statement works. And I can see Z does not print anything out, Z is error, and error is true. Or Z is NaN and error is true. So I've tested both my branches, and here we can see what my function calculation function looks like. Moving on, question number 5. Here we go. Write a function file, A, BH, ABV, concatenate. That takes 2 arrays. So once again, I have 2 arrays. Important. A and B have arbitrary sizes. So make sure I write things generically. And returns 2 matrices with modified A and B, concatenate horizontally, ABH, and vertically ABV. So if, once again, another branching statement, if the number of rows in A, so I'm going to go ahead and determine the number of rows, are A and B are different, then concatenate A and B horizontally by removing extra rows from the matrix with extra rows. If the number of columns in A and B are different, the function must assign ABV with removing the extra columns. And if A and B are the same size, then there's no problems. Okay, so I'm going to say A equals rand I 4, 9, not terribly important, 3, 4. B equals rand I 5, 2. So here's my function code. I'm going to use A and B in order to go ahead and do things. First thing I do, I need the sizes. So rows in A, row or columns in A equals size of A. Same thing for B. Copy, paste, rows in B. Okay, so first I'm going to go ahead and concatenate horizontally. Which means I need to have the same number of rows. So if row A is not equal to row B, then I'm going to go ahead and do something. So if row A, I'll do it this way. If row A is greater than row B, do something else if row B is greater than row A. And that's, so here they're the same. So here's are the same, which means A, B, H would be A placed next to B. No problems. That's this third branching statement down here. So now the first one. If the number of rows in A and B are different, the function must assign ABH with A and B concatenated horizontally. So if RA is greater than RB, that means A has more rows, which means ABH is going to be A, which part of A? Rows 1 through RB, all columns placed next to B. This is one of the ways to do it. Lots of ways to do it. Okay, so I'm going to go ahead and just take the first B rows of A, because B has more rows, or because A has more rows. Helps if you have an example. So here's B has more rows here, so it'll work on the other one. But here, let's say these were flipped. Let's say A was B and B was A. I'm going to take the first 3 rows, so 1 to RB. Same idea here, except now it's flipped. I'm going to take all of A, and now the first 8 rows of B. This is my example down here. I'm going to place A next to B, but only the first 3 rows in B because A only has 3 rows. So that's concatenate horizontally, and then concatenate vertically. Same idea, same process, except now with columns. If CA is greater than CB, else if CB is greater than CA, else. Otherwise, they're the same, so ABV would just be A placed on top of B. A stacked on top of B. Remember, commas put things next to each other, so do spaces. Semicolons stack things on top of each other. Okay, so if A has more columns, like it does here, then I'm going to go ahead and say ABV equals part of A. Which part of A? The first whatever columns of B of A that match B. So in this instance, the first 2 columns of B. So 1, 2, CB. stack that on top of B. If B has more columns, so if they were flipped here, then I would say ABB equals the same idea, except A is normal. I only take the first B columns of A. Okay, so here I have examples. I'm going to go ahead and print out ABV, ABH, and ABV. Make sure they match what I expected. Put that on the side there. There we go. Now I can see all my code. Okay, so right now, A has less rows and less columns than B. Woohoo! And I have an error. Okay, so what does A look like? A looks like this. What does B look like? B looks like this. So here, let's see if I can concatenate them horizontally. Let's try. Horizontally, A has three rows, so I can get it in the first 3 rows of B. That one looks fine, but there's something wrong with concatenating vertically. Which means that here, if CA, is that greater than CB? No, which means CB must be greater than CA. Yes, so let me go ahead and look at A. A looks like that, and I'm trying to stack that on top of this. Okay, note, I didn't change this one. Copied and paste and failed. So let me go ahead and check that again. Okay, that works. ABV. Okay, stacked appropriately. So now let me go ahead and change my example up here. Let's make these flipped. Make sure the rest of my code works. So here, ABH, yep, ABB. There we go, perfect. And then let's check to see if they're the same. Just as a note, to run my code without pressing the run button, I'm pressing Control Enter. It allows you to run a section of code at a time without pressing run. It does not save your code though when you do that, so just keep that in mind. Okay, so my code works, so now I go ahead and change it into a function. If you are going to do this, make sure you name your variables the same. So A and B were my inputs. I just put those at the top. ABH and ABB are my outputs. That's what I'm defining somewhere in my code. And then every function has an end. Saved it. Concatenate. And then I can go ahead and test it using the code that it gives me. Okay, it's random numbers, so these numbers over here don't match, but the sizes match, and that's what I'm more interested in. And the fact that there's no errors. Once again, if we want to test it thoroughly, we would also check to make sure that these are flipped, just in case the rows and columns are different, and then check to see if the rows and columns are the same. But there we go. There's my solution for concatenate. That's one way to do it. There's other ways to do it. This is the way that makes most sense in my brain, where I'm just creating new arrays by placing this next to this next to this, placing this on top of this. So thinking about it that way. Okay, question 6. Make this work. Question 6. Write a function file, double row, triple column. It takes 2 integers, m and n, and creates an array A of size m by n, where every element of A will be 2 times the row number and 3 times the column number. Okay, I'm creating an array. There's lots of ways to do this. The way that comes into my mind, first and foremost, is a for loop. But there's more than one way to do it. I'm going to go ahead and just write my function right away. If you name your functions incorrectly, it's not the end of the world. It'll make our lives a little bit harder for grading, but don't worry too much about misspelling something, like triple with a capital R. It's okay. It's not the end of the world. Okay, so for I equals 1 to m, or j equals 1 to n, this is the way I think to do it. Where a is zeros, then a of I comma j equals 2 times I plus 3 times j. This is the way I think to do it. More than one way to skin a cat. If I print it out, I can see it matches that. Where I goes through the number of rows, J goes through the number of columns, and I'm saying A in this row in this column, it's 2 times the row number plus 3 times the column number. I can change this to R and see if it makes more sense. Other ways to do it. R equals 1 to m, C equals 1 to n. I believe I can do this with array multiplication. A equals R times C. See if that works. Nope. C times R. R looks like this. One of them needs to be transposed. R transpose times C. It would be 2 times transposed. No, they're not multiplied. See if that works. Nope, that doesn't work. There's probably other ways to do it. You probably could do it in a single loop as well, but this is, just scratch that. Thought I could do something fancy, but apparently not for this problem. I think because they're added together, it's 2 times I plus 3 times the column number. That complicates it. This would be 2, oh gosh, matrix multiplication. Requires a little bit more thought, but here's a way to do it. Using nested loops. Yeah. So that one's done. You can think of a different way. That would be great. I'd love it. Question 7. Oops. Missing a 7 there. Write a function, checker, which creates a checkerboard pattern of 1s and 0s with m rows and columns. The 1 position should be 1. The remaining rows and columns should alternate between 1 and 0. Okay, I'll do this one in a function right away as well. Function checker equals checkerboard mn end. So first things first, checker is filled with zeros. So 3 by 3. If you want to do it piece by piece and write your function right away, you can do it this way. Just assign m with a number, 3, n with a number, 4, and then execute your code one at a time. Starts with zeros. So then I want to go ahead and start modifying checker. So checker 1, row 1, 1 through 2 to the end equals 1. So let me go ahead and run that, make sure that works. Okay, that's the first one. Do another one. 2 to 2 to end. Okay, that's that one. Copy and paste again. 3. Odd ones again. And notice there is a pattern. So I can go ahead, anytime I have a pattern, I can write it in a loop. For I equals 1 to the number of rows, which is m. This is what I'm repeating. I'm deciding between 1 to 2 to end and 2 to 2 to end. So I can go ahead and write an if statement. There's ways to do it without an if statement, but I can say if I is odd, so rem I, comma 2 equals 1, then this is my checkerboard pattern. Else checker I is 2. There we go. So that's the pattern I am repeating. Can't run my... Save it. Test it. C equals checkerboard. I can do 3, 4 matches that, but I want to go ahead and choose something bigger. So 5, 4. Yeah, mistake. Okay, yep, I can see that. What if I have 7? Okay, it's matching. Another way to write it is to just go ahead and instead of doing a branching statement, I can just go ahead and put this remainder in here right away. This is another way to do it. Thought it was another way to do it. It should be another way to do it. Remainder. Yeah, should be, plus 1. There we go. That should work. There we go. Oh. Ooh. I want this first to be 1, and then this one to be 2, this one to be 1. There is a crafty way to do it. It would be based on I. There is a crafty way to do it based on I, but this also will work. My problem is when it's 2, the remainder is 2. And I want it to be the other way around, so I can knot this. That work? That works. So I'm saying not the remainder, since this is 1, 0, 1, 0, I want to flip it. So the opposite of true is false, the opposite of false is true, etc. So I just put the not in there to do a crafty way of converting 1s to 0s and 0s to 1s. And there we go. That works. Okay, so that is question number 7. Question number 8. Write another function file. Those are our favorite. Mass substance that takes in a volume in meters cubed. Okay, so it's a unit conversion problem. Maybe. Similar to your pressure from homework 6. And the S as a string. Double or single quote, so string scalar is a double quote, or single quotes is a character array. Double quotes, you can use equals, you can use plus, all that fun stuff. With string quotes, you need to use string compare and string cat. And returns the corresponding mass of a substance. So your function must do the following. Use a branching structure. So here it explicitly tells us to use a branching structure instead of saying if. To calculate the mass of the substance as the volume times the density. So here's my formula. Volume times the density given the following elements. Volume is an input. Density comes from this table. So my table, I'm deciding which density to use. Display the mass of the substance in the following format. Once again, I'm not told which one to use. I can use disp or fprintf. There's no digits past the decimal point here. That's listed there on purpose. You can choose to your freedom of which ones make sense. And then if the substance is not recognized, so here's an otherwise. Assign M with NaN and display the message unrecognized substance. So once again, display the message at display or fprintf. Okay, so go ahead, start with some code. So let's say V is 0.25. and S is oil. If you don't want to worry about case sensitivity, you can always just lowercase your input. So here's my function code. I can say S equals lower. S. Go over here, help lower. Converts to lowercase. If you want to check it, make sure it works. So there's S is oil. This is oil. Yeah. Okay, so now I need to go ahead and choose my density. My volume is input. I need to choose my density. If S equals water, else if S equals air. We are comparing S with equality to multiple options, which means I can also use a switch statement. If I want to use a switch statement, I'm switching on the variable S, and my cases become my options. So case 1 is water, case 2 is air, case 3 is oil, case 4 is mercury, then I have my otherwise. Okay, so there's my branching. I'm choosing between my density. Density equals 1,000. Density, you remember you don't need to worry about units. 1. Density equals 800. Our code does not keep track of units. It is your job to keep track of them yourself. Make sure everything is in the proper units. Otherwise, density equals NaN. Whatever. Here, we'll see what happens. So now my mass equals volume times density, so V times D. If D is NaN, see what happens. M equals 0.25 times NaN. I get NaN. So this handles my errors for me, essentially. Okay, so now I need to go ahead and display my results. Here I'm going to print out my error. I'll print it out here. If D equals NaN, or is NaN, I'm going to go ahead and print out my number, or print out my message. Unrecognized substance database under. There's my first one. Otherwise, I'll display my message. Disp. My volume V plus meters cubed. That should be a cap. Plus meters cubed of spacing everything out. M, nope, of S, my substance, plus equals plus M. This is what it would look like with disp. I can go ahead and check my code. M equals substance. I'll just run it, because I didn't put in my function yet. Really use the keyword end. I have an extra in there. Run it. My substance is oil. So I converted it to water to lowercase. So when I compare it, I want to go ahead and compare it to all lowercase. And then I spelled oil wrong. Okay, 0.25 milliliters. Okay, that matches. Note it has the 0.00 once again. It's up to you on how you want to do it. If you wanted to use fprintf, it would look like this. And to be honest, if you're combining text and variables like this in a much more give and take method, I would suggest using fprintf. 1.2f m cubed of %s equals percent point f kilograms, new line. I'm inserting v, s, and if you want to do it using disp and string scalars, you can do v placed next to m cubed of placed next to s, placed next to equals, placed next to m, placed next to kilograms. All three of those should get you the same. There we go. Should get you the same. I need to convert these to string to num. Doubles faster. Just going through some. To be character factor string scalar. Answers NaN. V. My code stopped working. But it is working. What's V? V is 0.25. So if I do string to double V, it's NaN. But V is a number. Oh my gosh. I'm supposed to do num to string. Oh. Those little silly mistakes. There we go. So note with fprintf, I have more explicit control over how many digits pass to decimal place. But all three of those will be fine. All three of these are valid ways to convert our string. So last thing I need to do is go ahead and convert it to a function. Function m equals substance mass vs this. And then my function end. Now I can go ahead and test my code with the examples 0.25 oil. Here we go. 0.01 mercury. 136, and then this one will actually still work. That one still works because we converted it to lower. But I can go ahead and throw in some garbage, and obviously it's going to be unrecognized substance database under construction. So these are just some examples, ones that you can use, but feel free to make your code more robust. You do have a little bit more freedom when it comes to creating your code on the midterm once again, because we're going to be manually grading everything. Okay, woo, almost done, right? Moving on to question 9. Write a function file, uncorrupt removed columns equals remove columns A, which takes in an array of A and removes the columns, so deletes. That's a terrible way to say that, or write that. DELETES. That have at least one value of -999. So here's my invalid value. That's what I'm interested in. I'm detecting based on this value. So that means I'm making decisions. Which means I need branching. Assign uncorrupt with the matrix A with the columns removed, and assign removed columns with the indices of the removed columns. Okay, I'm gonna do this one at a time. I'm gonna go ahead and look at A. A is 7, 4, 8, 1, 8, 7, -99, 9, 1, 8, 2, 3, 9. It's important whenever you're writing your code that you go ahead and write it generically, because this is one example, the negative 999 can be anywhere inside of the matrix, which means that you want your code to work for any matrix A that has anything inside it. And it just deleted everything. New script. Okay, I guess I'm rewriting it. MATLAB Online tends to do that, so make sure you save everything all the time. So that you don't lose your code. And copy and paste your code into your exam on UB Learns whenever you're done. You can always go back and change it. Okay, I have this. A looks like that. I'm gonna go ahead and detect which columns have negative 199. So there's lots of ways to do this. I'm gonna go ahead and start by saying grab. No, I'm gonna start by saying yes, no equals A, where A equals negative 999. What this is gonna do is it's gonna give me a logical array where anywhere there's negative 999. Then I'm gonna go ahead and sum yes, no, count equals sum, yes, no. See what that gives me. Okay, that gives me the sum along my columns. So that means there's a 1 here. So I'm gonna go ahead and grab the locations. How do I do this? I mean, I know how to do it. I'm just trying to think of how you guys would do it. Location 3. I know what I'll do. I'll make columns 1 to the size of A. Column 2. There's all my columns, which means I want to grab the removed columns. RMBD calls, you can honestly name it whatever you want, is the part in columns where y no count equals 1. So if A looks like this, I want to remove column 3. If I put a negative 199 also here, I want to remove columns 3 and 4. Okay, so that works. That's one method to do this, using logical indexing. And then I can go ahead and remove them. So A, which part of A? All the rows in my removed columns. We'll delete. There we go. I've deleted all the rows with negative 99. This is one way to do it. Another way to do it is with loops, where I can go ahead and write a loop. It essentially does the same thing. For R equals 1 to size of A, comma 1. For C equals 1 to size. If R comma C equals negative 199, then or remove columns as an empty array, then I can say removed columns equals So A looks like this. Here, I'm starting with remove columns as empty. And then I'm iterating through. And the first time it runs into -999 is going to add in the 3. The second time it goes through, it's going to add in the 4. Or the next time it goes through, it's going to add in the 4. So here I'm adding them one at a time. So this here is kind of like a running sum with arrays. It's a growing array, we can call it that. It changes every size. That's what the error warning says, but that's fine. And then I can go ahead and delete. Here's the same thing. Delete them. Delete the invalid column. So here's another way to do it. There are other ways to do it. You could do this with one loop and just iterate through the rows or iterate through the columns and just detect, okay, the sum. We'll do it another way. Option 3. 4, spelled correctly. 4, C equals 1 to the size of A, comma, to the number of columns. Okay, so for the number of columns, I want to go ahead and determine how many invalid values there are. So, invalid count equals sum of A. Which part of A? All of the rows in column C equal to -99. That should work if invalid count greater than 0, then here I can do this. I got small. This one should work too. There might be some errors. Let's go ahead and highlight it. A still looks like that. Evaluate. Yeah, 3 and 4. So invalid count. So sum of A comma C is the single row in the column. I'm counting, okay, how many values in that column are equal to -999. This is very similar to homework 6, problem 2. If that count is greater than 0, then I'm going to go ahead and add to my remove column, same way I did before, and then delete all of the ones that I detected. So here's 3 ways to do the same thing. This is without looping and branching, just with logical indexing. Here's with nested loops, and here is with a single loop. So the last thing I need to do is go ahead and convert this into a function. So function, whoops, didn't call it. A RMVD calls equals remove A. I did not call it removed column or uncorrupt, but that's essentially what this is. Uncorrupt, it's A after I remove the columns. Just a note in terms of variables, you can name these variables over here whatever you want because it's a function. They are completely isolated from the command window down here. They are their own separate thing, so I can call them whatever I want in here. I can call it A and B. Or B and C. Ah! Forgot to remove that from the top. Did not give me my removed columns. Did I name it correctly? Yeah, I did. Yeah, it's 3 and 4. It's not returning removed columns the way it's supposed to. Let me comment out these options. Just do the first option. There we go. That one's working. I don't know why the last one wasn't working. Let me comment out option 1 and then leave in option 2. Yeah, that one works. Recomment option 2 and uncomment option 3. Okay, that one works too. I don't know why it wasn't giving me the correct C value before. There's 3 ways to do this problem. Okay, on to question 10. Write a function file L equals parabola AH that takes in values for A and H as positive integers. Note, positive integers. And calculates the arc length. These are integers, so they are scalars. So we don't need element-wise operations. It calculates the arc length given by this equation. Branching. If A and H are not positive integers, your function must assign L with NaN and error invalid entry. If they are valid inputs, assign L using equation 9.1. Okay, let's go ahead and do this. Starting with my function right away, for some obscure reason, if something, I'm gonna go ahead and write my equation. L equals square root of A squared plus 4 times H squared. Don't forget to put in an asterisk every single time you are doing multiplication. Make sure you put parentheses around all of the bottom parts of your fractions that have more than one variable in them. You use the right math functions. Like it says ln in here, you should use log. Okay, so this here is a square root function. This here is a square root function. This is the log function. This is another square root function, so make sure you pay attention to those. Previously above, we saw the exp function. Here we saw the exp function. So make sure you're using the right function for the right calculation. Okay, so I have L calculated. We can test it. L equals parabola 4, 6, 15. Yeah, that's right. Okay, so I did my calculation correctly. Once again, A and H are scalars, so we don't need to use the element-wise operation. But first, we need to check if they are positive integers. So if A is greater than 0. And H is greater than 0, I can do this calculation. That's to check if they're positive. Otherwise, L equals N and display error invalid entry. If I want to check if they're also integers, let's see. Integers, that means if I round them, it equals itself. Right. So let me go ahead and test it. 4 and 6, obviously that works. 4.5. Error invalid entry. 6 invalid entry. Negative 10. 4. Invalid entry. Positive 10. 4. Valid. Okay, so there we go. That's one way to check to see if they are integers. I don't think this problem was written with that in mind. You can technically calculate the arc length of a parabola in order for any valid a and h, but it says valid integers or positive integers, so this is how you can check to see if they're integers. Note, I'm using and to combine these. All of these need to be true. A needs to be positive, and h needs to be positive, and a needs to be an integer, and h needs to be an integer. Okay, so all of those things. There's no ors in there. It's not one of the options. It's all of the options. All right, question 11. Write a function file. C equals a, b, s, b that takes a and b as two vectors. So they are vectors of the same length. And return c as a vector of all the elements in a and b that are even, and d as a vector of all the elements in a and b that are odd. Okay, so note, I don't need branching in here, but in order to get all the even values and all the odd values, I can use logical indexing. I can also do this in a loop. I'll show you guys both. So function c e equals a b s b b a b. Okay, so C is going to be all the values in A that are even and all the values in B that are even. So A, what part of A? A, where A is even. A, where the remainder of A, 2 equals 0. Place next to B, which part of B? The part where the remainder of B, 2 equals 0. D would be the other piece, where it's odd. And the remainder equals 1. No, don't delete. Save. Rename. Woo! Okay. Let's see, me for some reason. I might be missing a closing. Oh, B needs a closing. Pay attention to those error statements. They are useful. Oh, B doesn't need a closing. Why are you yelling at me that loud? Oh, I don't have equal signs. Equal sign. There we go. There we go. Then go ahead and look at an example. 7, 1, 9, 10, 7, 8, 8, 4, 7, 2 equals 8, 1, 3, 1, 1, 9, 7, 4, 10, 1. They have to be of the same length. It doesn't say to check whether or not they're the same length. We're just going to assume that they are the same length, so do not worry about checking for that. And then a C, D equals A, B, S, B. A, B. 10, 8, 8, 4, 2, 8, 4, 10. There we go. It works. So this is one way to do it. Notice it's 2 lines of code. Another way to do it would be with loops. So 4I equals 1 to the length of C. Nope, the length of A. If C and D are empty brackets. If I remainder of A, round A, I divided by 2 equals AI. So this is another way to check if something's even. You divide it by 2. So if I take 8 divided by 2, that should be equal to 8 divided by 2. However, if I take, if I round 9 divided by 2, I will get 5, which is not equal to 9 divided by 2. So if it's even, then go ahead and add it in C. else, go ahead and add in D. And then repeat for my B vector. Here's another way to do it. Oh, same answers. So here's another way to do it. Option 2. Notice option 2 is longer, but it works fine. It works fine. If that one makes more sense to you, that's fine. This is a little bit more conceptually abstract for students. This can make more sense, more logically, going through one number at a time. It just depends on where you're at in your programming skills, which is fine. Everybody's at a different spot. So starting out with C and D as empty arrays, iterate through all of A. If A has an even value in that location, add it to C. So take C, whatever was previously there, and place it next to A. And if it's not even, then place it in D and then repeat for my B values. So that is AVS times B, or AVS-B. 2 more problems. So, question 12. Question 12, write a script file. Woo-hoo! Here's our first script file. Like I said, all of your exam questions are going to be functions. But here is a script file. So here, solve the system equations. And I have a big system. So I'm going to go ahead and start by writing my A matrix. Equation 1, 2, 3, 4, 5, 6. X1, X2, X3, X4, X5, X6. And then I go ahead and place my numbers. So -1, 3, 2, 8, 7. And then B is 91. And then -2, 3, -7, -6, 10, -5. There's not a lot of zeros in here, which makes it nice and relatively simple to do. 6, 5, -5, 8, -5. Ooh, there's a 0 in there. Which 0 is it? X3. That's a 0, -5, 8, -5, -8. -7, -5, 10, 0, -7, 9, and then 0, 4, -3, 4, -5, -3. It might help to write it out on paper. Your exam questions will be printed out for you. So bring a utensil. Bring a writing utensil. So that you can do this chicken scratch that I'm showing you guys along the side. Okay, so to solve this equations, I need to write in my A values. On -1, 3, 2, 8, 7. There we go. Stacked on top of -2, 3, -7, -6, 10, -5. Stacked on top of 6, 4, -8, 5, 1, 7. 6, 5, 0, -5, -8, -5. And then -7, -5, 10, 0, -7, 9. You will not be asked to do anything by hand for solving systems of equations. The final exam will be all linear algebra. So that's where we're going to really focus on your linear algebra skills. Don't worry about it too much for the midterm. You should still know the concepts. So you should still know how to use determinant, how to use inverse. You should know how to calculate. You should still know how to calculate those using MATLAB. You should still know the concepts. If something's singular, invertible, non-invertible, non-singular, all that fun stuff. What makes a matrix invertible, non-invertible? Because all of that's valid. But we're not going to ask you to solve it by hand. And this means that x equals a left divide b. Woo, 3 lines of code. Run my code, make sure it works. It doesn't work. I'm going to save this first. I missed a number, probably as I was talking. And then I want to go ahead and display my results. So I'm going to use fprintf. I want to print out x followed by a number equals 0.2f x/n. What numbers do I want to do? 1 through 6 placed on top of x. And then I can nicely align them if I want to. So take up backspaces. Woohoo, they're nicely aligned. And here we can see my answers. They're nicely aligned. They're integers, which means I probably entered things incorrectly. It doesn't look pretty. I didn't align everything, but that's fine. You don't have time. If you do have extra time, then you can go through and you can nicely align your numbers and make it up and double check it to make sure you got it all right. But you don't have to. But sometimes it's nice when you're typing things in. Just to double check your answers and make sure it all looks fine. Okay, so that's system. Last problem. Woo! Write a file y equals tan theta. So we are calculating a piecewise function. Anytime you have a piecewise function, you're making decisions based on these conditionals. Based on these questions, what is your value for theta? There's multiple ways to do this, but theta is going to be a vector. I can go ahead, I'll just comment that out. That one. And just start with theta equals linspace 0 to 2. Note, this will give me 100 values because I did not specify a number. But that's what it is. So then I want to go ahead and calculate y. There's multiple ways to do this. I'm going to go ahead and say for I equals 1 to the length of theta. Y is going to be the same length as theta, so it's going to be zeros, size theta. Then I'm going to fill in y one at a time based on what theta is. So if theta I is greater than or equal to 0, and theta I is less than pi over 2. That means yi equals 6 times 2 times theta I minus 0.5 times sine of theta I divided by pi. Else if theta 2 and theta I, then yi is equal to this equation, 6, I lost my music, no I didn't, 6 minus 3 times 1 minus 0.5 times cosine of 3 times my parentheses. That one. One. I think we're good. I think I have one. Else if theta I is greater than or equal to pi and theta I is less than or equal to less than 3 pi over 2. yi equals this equation. Else if, no, but just else if theta, I'll just do this. Assume it doesn't go over 2 pi. That's we want to say that theta I is greater than or equal to 3 times pi over 2. And theta else, I don't know, pi I equals NA. Okay, last equation. Okay, and my equations. My code. I'll save it first. On my code. See if it works. I did something wrong. Unrecognized function or variable. Line 14. Pi. There's my figure. It looks like it's supposed to, so we'll say I did it correctly, which is great. That's great to hear. I don't need to go through and debug that. But this is one way to do it. If I go ahead and wrap it in my function, I can go ahead and call my code from down here the way that they stated. If you do this, make sure you do not put your inputs inside of there. So theta should not be in there. We should move it out. That's why I initially started by writing them above and my function code below and converting it later. My plot is in there. Okay, it works. This is one way to do it. Another way to do it is just with logical indexing. So I can say y. Which part of y? The part where theta is in this area region. I don't need the i's in there anymore. Equals this calculation. But rather than saying theta I, now it's the part of theta where theta is in this region. You can see there's my big long equation. Modify y, which part of y? The part where theta is between 0 and pi over 2. Modify it so that it's 6 times 2 times theta, which part of theta? The part where theta is between 0 and pi over 2. Minus 0.5 times sine of theta, which part of theta? Where theta is between pi over 2, etc. I could break this up into location 1. And use L1 in here instead, just to shorten my code a bit. Oh, there it is. And then I can repeat for L2, where L2 is the part where theta is in that area. And I can say y of L2 this calculation, where I'm using which part of theta? The part where it corresponds to L2. And there we go. Same thing. Same idea. If I run my code, it should still look the same. Note, you cannot use double ampersands with arrays, which is the bane of my existence. And if I plot, there's my code. Okay, so that's another way that you can write this piecewise function. So there's more than one way to write pretty much all of these files. Okay, and that is 13 different problems that we've solved. So we are done. Go through them again, see if you can do different things, compare my solutions to the way that you did it. And that is generally a good enough practice in order to get a general scope of the problems for the exam. Some of the problems were a little longer than what you would expect on the exam. Some of them were a little shorter than what you expect on the exam. But a good general idea for what to expect when it comes to the midterm.